Hi guys, today we're going to talk about electron configuration, so you should have your notes out. Now I'm going to go through this rather quickly, and so you'll probably need some time to fill in some of the portions, so you can always go back and pause and have time to write in all the things you need to write in. So electron configurations, here we go. So after today, you can explain the organization of electrons, and then we're going to find out what an energy level, a sublevel, and an atomic orbital is. Okay? You'll be able to see the shapes of them. Oh, don't mind me as I play with the mouse. And then we're going to predict how many electrons are held in each energy level. And so the quantum mechanical model of electrons is the most current understanding we have of positions of electrons in an atom. And the quantum mechanical model says that we cannot say exactly where an electron is, but we can have a probability of where that electron is. And we use electron configurations then to show how the electrons are distributed within the atom. So, do you remember when you envisioned an atom having a single center and then rings around that center, kind of like that? That's our nice Bohr model of the atom. Well, it turns out it's a little more complicated than that, okay? That wasn't the whole truth. You can't handle the truth. So, principal energy levels, okay? N is the principal energy level, and there are 4 principal energy levels. So we just creatively describe them as 1, 2, 3, and 4. And the principal energy level describes basically how far away an electron is from the nucleus. And so if an electron is in the n equals 1 level, it is closer to the nucleus than something that's in the, let's say, n equals 3 energy level. Energy is going to increase, and then just kind of circle that or highlight it. Energy is going to increase as you move farther from the nucleus. So our electrons that are the lowest in energy are going to be closest to the nucleus. And our electrons that are the highest in energy are going to be the farthest away from the nucleus. So within each energy level, electrons occupy something called sublevels. Okay? So what is sublevel? A sublevel is going to correspond to areas where an electron can be located in an atom. We represent sublevels by letters. The most common are the first 4, S, P, D, and F. There is a G, but we don't use a G. So if you write this list down, highlight the first 4, S, P, D, and F. Sublevel types. There is an S sublevel, and there's room in your notes to do a little kind of picture of it. Okay, it is spherical, this one. I'm not very artistic, and I can even draw this one. So it is a circle. An S sublevel is spherical. The S and the S go together. That's kind of nice. A P sublevel is shaped kind of like a dumbbell or a figure 8, a sideways figure 8 sort of. A D sublevel is like a clover, and then an F sublevel is a double clover. So just kind of sketch those images in your notes. The sublevels that are in energy levels, notice energy level 1 has 1 sublevel, so that's 1s. The second energy level has 2 sublevels, so we have 2s and 2p. The third energy level has 3 sublevels, so 3s, 3p, 3d. The fourth energy level has 4 sublevels, 4s, 4p, 4d, and 4f. And then the fifth one technically has 5, but the periodic table only goes far enough to need 4 of them. So 5s, 5p, 5d, 5f, and if we needed more, if we had more elements on the periodic table, we could even possibly get to a 5g. So each sublevel basically is oriented differently in three-dimensional space, and each orientation then is called an atomic orbital. Atomic orbitals can hold only 2 electrons. Highlight this and circle it and put a little star. So each atomic orbital can only hold 2 electrons. All right, so an S sublevel, sorry about that, my PowerPoint's going a little nutty. Okay, there we go. An S sublevel has 1 orbital. And remember, each orbital can only hold 2 electrons, and so there are 2 electrons in the sublevel. A P, the dumbbell, there are 3 dimensions to that, and so it has 3 orbitals. Each orbital can hold up to 2 electrons, and so the max number of p electrons are 6. A d sublevel has 5 atomic orbitals. That's our clover. If done 3-dimensionally, there would be 5 orbitals, so it can hold 10 electrons. And our F sublevel, our double clover, actually has 7 orbitals and can hold up to 14. The G you are not responsible for, but if we had enough elements to need a G, it would actually have 9 orbitals, and then that would be 18 electrons. Here it is again. This is super sensitive. So orbitals for a particular sublevel are similar in shape, but they're different in size and in orientation. Looking at the number of electrons in each energy level, okay, the first energy level has an S orbital, 2 electrons. Second energy level has S's and P's, 8 electrons. Third energy level, S, P's, and D's, 2 plus 6 plus 10, 18. Fourth energy level, 2 plus 6 plus 10 plus 14 equals 32. On the unit test for this, there is a question that talks about an energy level and how many electrons will be in that energy level. So you might want to star or highlight this chart on your notes because you will see it again. So in general, an S orbital is our lowest energy, followed by a p orbital, followed by a d orbital, followed by an F. So S will fill first, then D's, then P's, then D's, and then F's. Because electrons prefer to occupy the orbitals that require the least amount of energy. We all like to do work where we require the least amount of energy. So electrons are no different. All right, that concludes the first part of our notes. So let me get out of that one. And then I do want to also look at writing electron configurations. We're not going to do orbital notations today, but we are going to look at how to write electron configurations. So this is the back part of that first page of notes that you have. Okay? And so we want to look at how to write an electron configuration for an element. So an electron configuration is basically a method for showing you the arrangement of electrons in an element or an ion. We'll do ions tomorrow. So electrons are going to fill the first energy level before they go to the second one, before they go to the third one. Within an energy level, they will fill the S's first, then the P's, then the D's if there are any, then the F's if there are any. For a neutral atom, remember that our protons equal our electrons, which equals the atomic number. And for our examples today, we'll take a look at neutral atoms. So, if we were to write the electron configuration for hydrogen, hydrogen has one electron, so its electron configuration would be the first energy level, the S orbitals fill first, and there's one electron. So 1s1. The energy level is the number in front, the sublevel is the S, and then the number of electrons. All right, try helium. Helium has 2 electrons. So what do you think the electron configuration for helium will be? 1s2. Now remember, the maximum number of electrons that our S sublevel can hold is 2. And so if we get anything bigger, we're going to have to put them somewhere else. Look at lithium. Okay, well our 1s2, lithium has 3 electrons. Okay, so the first 2 are going to go into the 1s2. But there's still another electron left, and we're out of energy level 1. So we're going to have to go to energy level 2. And then we'll start with the S's. And so our electron configuration for lithium is 1s2, 2s1. There is a principle called the Aufbau principle, and that states that electrons are going to enter sublevels with the lowest energy first. And so every element's electron configuration is going to start with 1s because it's always going to go to the lowest one first. So highlight or put a star next to the Aufbau principle because we'll have to be using that later in the unit as well. All right, nitrogen. Okay, nitrogen has 7 electrons. All right, so let's think about this. The first energy level, so we're going to have 1s2, and then we're going to have 2, the second energy level, we'll do the S's, so that's 1s2, 2s2, so that's going to be 4 of the electrons, and then in the second level we have S and P sublevels, so from there we can go to the P. So our electron configuration for nitrogen is 1s2, 2s2, then we go to we're still in the second level, so we'll do 2p3. All right, how about magnesium? Think about magnesium. Well, if you look at your periodic table, you'll notice that it is in row 3 of the periodic table. So we'll do 1s2, we'll do 2s2, we'll do 2p6 because we'll fill up all that. Then we're going to have to go to the third energy level. Remember, our third energy level has S's and P's and D's. And so the S's will fill first. So 1s2, 2s2, 2p6, that fills all those guys up. Now 3, now we're at 3. So we're 3s2 for magnesium. For elements that have more than 18 electrons, the sublevels are filled kind of out of order. So the next slide's going to be super important, okay? But the lowest energy sublevels are still filled first. So take a look, take a screenshot, or duplicate this in your notes because you notice our 1s will be filled first. So there's our 2 electrons that go there. Then our 2s, right? Our s orbitals can have 2 electrons, so there's our 2 electrons. Then we're going to go to 2p, right? And that will take 6 electrons. So let's put our 6 electrons in there, okay? And then we go to 3. So notice 3 has S, P, and D. So I'm going to go to 3s first. 1, 2, that can hold 2. Then I'm going to go to 3p, that can hold 6. Now, from an energy perspective, an interesting thing happens because the 4s sublevel is actually a little bit lower in energy than the 3d. So if we have any more electrons to place, we're going to do 4s, Then we're